On.
Hello, this is Mixmaster Math M cubed, your math teacher, otherwise known as Mr. Martin, recording to you from 16th Street in Manhattan, the greatest city in the world, Xavier High School, the greatest high school in the city of the greatest city in the world. Hope you feel privileged and realize how lucky you are today to be alive and going to this wonderful institution. Okay, we are factoring this and solving for x, and a lot of you did this in class already, but let me just go through. You're going to factor out an x, right? And the first step you should take is to factor it out and not worry about anything else but factoring out that x. The next step you should do is factoring that quadratic, and you guys should be getting better at factoring quadratics. You've been doing it since 9th grade, hopefully. Some of you since 8th grade, okay? This quadratic factors as x minus 3x plus 2. If you stink at factoring quadratics, just use the Google machine, and you can just Google factoring quadratics, and you can get a multitude of pages, probably a trillion pages of factoring quadratics with answer keys and everything where you can practice this, right? Okay, so now we're finding the zeros. That means I want to find the solutions to this equation where it equals 0. That's what a 0 is, or the roots. Okay, so now the zero product theorem says whenever we're multiplying numbers, if one of them is 0, then the whole thing is 0. So your solutions are made up of x being equal to 0, right? Or x minus 3 being equal to 0, or x plus 2 being equal to 0. And then you have to finish by solving each of those. And this one is already solved. This one you add 3 to both sides, right? And you get x equals 3. This one you subtract 2 on both sides, and you get x equals negative 2. Okay? A lot of you are like getting really, I don't know what to say, really lazy in how you're writing this down, and you're missing some of the steps. And when you miss some of the steps, you're missing some of the key ideas, right? And so I know you've been doing it since 9th grade, but some of you are doing it really poorly. Okay, next one, you want to make your own polynomial function which has those zeros. So what you can do is just imagine going backwards, right? What if the solution was negative 3? Then that means it had a factor of x plus 3. If the solution was 0, then of course it had a factor of just x. And 6 would have a factor of x minus 6. So there you can be given your polynomial. And what you can do now is you can multiply this out by foiling it, which would be x squared plus 3x minus 6x minus 18. And then you got to multiply an x by all of that. So you can multiply an x and get x cubed plus 3x squared minus 6x squared minus 18x. And I realize I didn't combine like terms yet. So you get x cubed minus 3x squared minus 18x. Okay, so that would be a polynomial. Let me call it p of x. That would give the solutions that we wanted. Okay, next thing is all functions that we've drawn like this. So we drew these before. We drew them as part of piecewise functions. All the things we've been doing. These are examples of These are examples of polynomial functions. This one is a polynomial function of a degree 0, right? Degree 0. See that? A constant graph or a constant polynomial has a degree of 0, just like we set up above in the notes. A constant term like 5 has a degree of 0. Any constant term has a degree of 0. Okay. Linear functions have a degree of 1 because you have an x to the power of 1 inside of it, right? And if you had a quadratic, that would be a leading term of some a multiplied by x squared, so 2 would be the degree, right? So we know all those already. Those are examples of quadratic of polynomial functions that you already know about. Some other example, some non-examples, and this one is not drawn that well. I don't like this one. Oh, sorry. This is another example, right? We're going to learn later how to figure out the degree of that polynomial, but for the most part, This is a polynomial. It's smooth. It doesn't have any jerking motion, right? It doesn't have any holes, any asymptotes. Okay, but this is not an example. This is a non-example. This is not a polynomial, and this is not a polynomial, right? This is an absolute value graph. So that one is not going to be a polynomial either. Okay, so this one with a jump and this one with a turn that's just like a jagged edge to it is not going to be a polynomial. Okay. So I'm going to stop and I'm going to continue the next video.